Magnetic properties of materials. On the basis of magnetic properties, material can be classified as A. Diamagnetic materials. Magnetic susceptibility is negative. B. Paramagnetic materials. Magnetic susceptibility is positive and less than 1. C. Ferromagnetic materials. Magnetic susceptibility is positive and is very high. Such type of classification is based on sign and magnitude of magnetic susceptibility of material. Diamagnetism. Diamagnetism is a property of those magnetic materials in which the individual atom or molecule does not possess any net magnetic moment of their own. That is, the valence electrons orbiting and spinning completely cancel each other. The diamagnetic effect in material is a result of inductive action of the externally applied field on the molecular currents. Diamagnetic susceptibility is independent of temperature, as effect of thermal motion is very less on electron orbits as long as it deforms them. For example, bismuth, lead, copper, silicon, diamond, etc. Paramagnetism. It is a property of those magnetic materials in which each individual atom, ions, or molecule has a net non-zero magnetic moment of its own. When such a material is placed in an external magnetic field of induction B, it tried to align the individual dipole moment in the direction of the field. Some of the examples of paramagnetism are platinum, chromium, etc. Ferromagnetism. It is a property of those magnetic materials in which each individual atom, ions, or molecule has a net non-zero magnetic moment of its own, like paramagnetic materials. The individual magnetic moment interacts with one another in such a way as to align themselves spontaneously in a common direction over microscopic volume, which forms domains. All the atomic dipole moment in a domain is lined up, leading to some net magnetic moment. For example, cobalt, iron, etc. Hysteresis. In case of ferromagnetic materials, the relation between I and H is not linear. When we place a ferromagnetic material in the magnetic field, it gets magnetized by induction. If the field strength is first increased from a 0 to high value and then decreased again, it is observed that the original curve is not retraced. The induction lags behind and follows a characteristics curve. This phenomenon is known as hysteresis, and characteristics curve is known as hysteresis loop. As value of H is increased, I also increases non-uniformly. If we increase H indefinitely, the intensity of magnetization of ferromagnetic material approaches finite limit known as saturation.